In this video, we're going to talk about equations in algebra, and most specifically linear equations in algebra. So an equation is a statement in which two different algebraic expressions are equal. And we can see here on the screen there's a few different examples of equations. In each of these particular equation examples, x is standing in for some number, and if we knew the value for x, then what is to the left of our equal sign would be equal to what is on the right of our equal sign. Now we'll talk about how we would go about solving these later on, but that is something that we're going to look towards later. When we're given these type of questions, we will typically be asked to solve them. Now, solving an equation means getting to the point where you're going to have a letter to one side of the equals on its own, and on the other side of the equal sign you're going to have a number. In other words, you're going to find a value for the letter that is in our equations. The letter itself is known as a variable. So we're going to find the value of the variable in the equation. And when we find that number will be a root of the equation. But before we can get onto that, we need to just talk a little bit about balance. So if you try and picture equations like a scale. So we can see in the first scale up here, we've got 4 plus 3 is equal to 1 plus 6. What's on the left of the equals is the same as what's on the right of the equals. Everything is nice and balanced. But in the next two, we can see that we have 2 plus 1, and it is not equal to 3 plus 7. So 2 plus 1 is 3, and 3 plus 7 is 10, and they are not equal. One is clearly larger than the other. So the scales are not balanced. And we've got the same thing in the third one here. We have 6 plus 2 is not equal to 3 plus 1. So in each of these cases, one side is larger than the other, so they are not equal to each other. At all times, when we're trying to solve out our equations, we have to try and maintain balance. Anything we do to one side of the equation, we have to do to the other so that we do not tip the scale in one direction or the other. So for example, in our first scale up here, if we took the 3 away from the left hand side and we just left 4, and then we had our equals, and then we had 1 plus 6. Well, 4 does not equal 1 plus 6. So that would not be a balanced equation any longer. But if we took our 3 away from the left hand side and also took 3 away from the right hand side, then our scales will be balanced. So that's what we're going to try and bear in mind. We've got our left hand side of an equation and our right hand side, and anything we do to one, we have to do to the other in order to get to a solution for the equation. Now what we're going to do now is take a look at some basic equations, and we're just going to solve these out and talk about how we go about doing that. Okay, so we've got x plus 4 equals 10 for our first one. Now we want the letter on its own on the left of the equation and a number on the right so that we can get a solution to the equation. We're looking to solve this equation. So since we want to get rid of our plus 4 on the left, we're going to take 4 away from the left hand side. So we're going to have x plus 4, and we're going to take away 4 in order to get rid of that 4. But to maintain balance, we have to do that on the right hand side as well. So on the right hand side, we're going to have 10 minus 4 as well. So now what we have on the left is x plus 4 minus 4. Well, plus 4 minus 4 is 0, so we just have x. And on the right, we have 10 minus 4, which is equal to 6, like that. So, nice and straightforward so far. Let's look to our next one. Now our next equation is very similar, but instead of a plus in between the two parts of our equation on the left, we're going to have a minus. And we want to get rid of our minus 6. So in order to get rid of a minus 6, we're going to add 6 to both sides this time. So we're going to say that x minus 6 plus 6 is equal to, and don't forget, if we do something to the left hand side, we have to do it to the right. So it's going to be 4 plus 6. Well, minus 6 plus 6 is 0, so we just have x on the left hand side, and 4 plus 6 is 10. So we get x is equal to 10. And that's how we would do the middle one. And the last one's a little bit different because there's no plus or minus this time. This time around, it's a multiply. It's 3x is equal to 15, which is 3 multiplied by x is equal to 15. Now what we need to do is we need to get x on its own. So we've got 3 of them. So what we're going to do is we're going to divide our left-hand side by the number in front of x, divided by 3. So we have 3x divided by 3. And if we do the same thing on the other side, we'll have kept the equation balanced. So 15 divided by 3. Well, 3x divided by 3 is just x, and 15 divided by 3 is 5. So that's us having solved out that equation. Now, you might have spotted this as we went through this, but there is a little shortcut method that we typically do in these situations. So we're going to take a look at each question again, but this time by approaching it a slightly different way. So we have x plus 4 is equal to 10, like that. Now, we're still doing the exact same thing as above, but we're just treating it slightly differently this time. We want to get x on its own. So the first thing we're going to do is we're going to take this plus 4 and move it from the left-hand side to the right-hand side of the equation. But when we do that, we have to change the sign from a plus to a minus. So our next line down, when we're doing it this way, is going to be x is equal to 10 minus 4. And if you look up above, in our previous way of doing this, we have x plus 4 minus 4 is equal to 10 minus 4. Now on the left, 4 minus 4 is 0, so we do just have x on the left, and on the right we have 10 minus 4, which is exactly what we have now. And our next line down from this, we're going to just go with x is equal to 6. So we're basically doing the same thing. This is just seen as more of a shortcut method, and approaching it in this way will make future questions a little bit more convenient to do. Let's apply the same altered approach to the second example here. So we start off with x minus 6 is equal to 4. Now we're going to move this minus 6 across the equals, and it's going to change its sign from minus to plus. So it becomes x is equal to 4 plus 6, which is exactly what we expect because it's what we saw from above. And we do that sum out, we get x is equal to 10, which is exactly the solution we got above. So we haven't done anything different realistically, we've just approached it in a slightly different way. And we've got the same thing going on over here. So for the last one, we have 3x is equal to 15. And we're going to take our 3 and bring it across. Now this one's a little bit less obvious. For the previous two, a plus became a minus became a plus. This time though, 3x is x multiplied by 3. So when we move the multiply by 3 across the equals, it becomes divide by 3. But what we don't have to do is we don't change it from plus 3 to minus 3. Because we changed it from multiply by 3 to divide by 3, that was enough. We didn't have to go about changing it from a positive to a negative. So we have x is equal to 15 over 3, which means x is equal to 5. So exact same solutions to all three of the questions, just with a slightly different approach. Now the last thing that we could be asked to do in any of these questions is to verify our answer. Although the other thing that we can also do with this is we can check our own answer to make sure that it works for us. Verifying your answer or checking your answer is just a matter of taking your solution, your value for x that you got, your 6 or your 10 or your 5, and putting it back into the equation to check that it satisfies the equation. So let's take a look at our first example. We have x is equal to 6, and we're told at the start that x plus 4 equals 10. Well, let's put 6 in and see if that works. So 6 plus 4 equals 10. Well, 6 plus 4 is 10, so 10 is equal to 10. So that checks out. If we're asked to verify our solution, that would be it verified. If we needed to check our solution because we were unsure, that's how we would go about doing it. Now let's do the same thing for the other two, just to be sure that we've got everything correct. So our equation here is x minus 6 equals 4, and x is equal to 10. So we're going to have 10 minus 6 equals 4. Well, 10 minus 6 is 4, and 4 equals 4. Well, that checks out. And we do this for our last one. We have 3x is equal to 15. That's 3 times x equals 15. And we figured out that x equals 5. So that's 3 times 5 equals 15. Well, that's 15 equals 15. So that checks out. So far we've seen the long way to solve out these basic ones, a slightly quicker way to solve out these basic ones, and how we would go about verifying or checking our answer for each of these basic equations. Now the last bit of this here, we're going to take a look at slightly more difficult equations. They're not completely impossible, but there's a few more steps involved to getting toward a solution for these. And for each of these, we're going to follow the second method that was shown above. So let's start with our first example here. We have 2x plus 16 is equal to 24. We're going to do this one bit at a time. The first thing we want to try and do is make sure that we have all of our letters to the left and all of our numbers to the right. Well, all of our letters are already to the left, but we need them on their own. So we're going to have to try and get rid of this plus 16 to start with. So our next line down from here, where we started off with 2x plus 16 equals 24, is 2x equals 24, and we're taking our plus 16 over, so it becomes a minus 16, like that, which means 2x is going to be equal to 24 minus 16, which is 8. And now from here we've got to get x on its own, so we've got to get this multiplied by 2 and move that across. So we're going to have x is equal to 8, and when we move our multiply by 2 over, it becomes a divide by 2. So we get x equals 8 divided by 2, which means x is equal to 4, like that. So that's our first one done out. Nice and straightforward, nothing too ridiculous there. Let's take a look at our second example here. We've got 4x equals 28 minus 3x. And this one's a little bit less obvious of what to do first. We're going to first of all need to move this minus 3x over to the left hand side. So we're going to have 4x. Now we're taking a minus 3x across, which means it stops being minus 3x and becomes plus 3x. And that is still equal to 28. Now 4x plus 3x is 7x. So 7x is equal to 28. And now we're going to move this 7 from here and bring it across. On the left hand side, this is multiplied by 7. So 7x means x multiplied by 7. And we bring a multiply by 7 across, it becomes a divide by 7. So we get x equals 28 divided by 7, which means x is just equal to 4, like that. And now we take a look at our last one here. Our last one, we have 7x plus 11 equals 3x plus 27. So we're going to need to move our plus 11 to the right hand side, and we're going to need to move our 3x to the left hand side. And we can do that all in one go. We don't need to go step by step. We can go step by step if it's more convenient for us, but we can do it all at once to make this a bit quicker. So we're going to our next line down is going to be 7x, and we're going to bring our 3x over, so it stops being plus 3x, becomes minus 3x, and that's going to be equal to 27, and we brought a plus 11 over, so it's going to be minus 11. So 7x minus 3x, that's 4x, and 27 minus 11, that is 16. So we have 4x is equal to 16. So 4x is equal to x multiplied by 4. We're going to move our multiply by 4 across to the other side, and we're going to get x is equal to 16 divided by 4, which means x is equal to 4. Now if we wanted to verify any of these, we would take our value for x, either our 4 there, our 4 there, or our 4 there. And I did not expect that to work out 4 every time. And we will put them back into any of the equations. So let's just take our third example just here. And let's verify this equation. Let's make sure that our answer actually fits. So instead of 7x plus 11, we're going to have 7 times 4 plus 11. And on the other side is going to be 3x plus 27, so it's going to be 3 times 4 plus 27. Like that. So on the left hand side, 7 times 4, that's 28 plus 11. And on the right hand side, 3 times 4, that's 12. That's plus 27. 28 plus 11 is 39. And 12 plus 27, that is also 39. So that checks out. So we know for certain that the value that we got for x in our third example here satisfies the equation. It is definitely a root of that equation. And that is the basics of linear algebra, or linear equations.